Hello, my name is Rob Earlam, a technical evangelist with Sitecore, and today we're going to start to look into Sitecore 10 and DevOps. In this session we're going to be focusing on Sitecore, Docker, and continuous integration. So when working with containers, your DevOps flow changes compared to when you were deploying directly into an IaaS or PaaS instance. The first action you're going to be performing is the automated build of your images when something changes that requires them to be updated, for example a code change. This is the continuous integration piece that we're going to focus on in this session. It involves building the images and pushing them out to a container registry, for example Azure Container Registry, commonly referred to as ACR. The second part of your DevOps flow will be the deployment of these images out to a container orchestrator like Kubernetes or Microsoft's managed version called Azure Kubernetes Service or AKS. This forms the continuous delivery part of your DevOps setup. So first, let's take a look at how these two elements come together to form a full build and release DevOps pipeline. So we start off with our developers, working away in their IDE of choice, making changes to the codebase. They finish their work and commit their changes into a repository, in this case stored in GitHub. Now we're using an Azure DevOps pipeline here, and we're going to monitor this repository and trigger a new build every time there's a commit to the repo. These images are built by Azure DevOps, and the new image version is pushed out into our ACR instance. But this isn't the only trigger we have configured. One of our base images might also have changed. For example, an update to the base Windows image or similar that would also need to trigger a new build to occur. Now, this point here is where our CI process ends. We have our new images built and they're available for deployment. But it's not the end of the whole process. Next, the CD elements start. Our release element is going to be executed and it's going to start our deployment process. The first thing the CD element does is to push the new version of the Kubernetes specifications into AKS, including pinning the deployments to the unique tag of the new images. AKS will now connect to the Azure Container Registry instance, pull down these new images, and build new deployments based on them. Of course, any Sitecore deployment isn't complete without a push of the content changes. Once the specs have been deployed, the content is then also pushed to the CM instance, running in AKS, and a publish is executed. Once this has happened, your end users can now browse the site and interact with the new containers running in AKS. Now this is a high-level overview of the whole process, but in this session we're just going to focus on the CI elements you can see here. In a follow-up session we're going to deep dive into the CD elements that were just hidden. So let's start to take a look at this CI process. In a previous session we showed how you can use Docker Compose to set up a manifest for how to build the different containers required for our application. Well, we leverage the same Docker Compose file when setting up our CI pipeline. This is great as it means the same instructions we use in our development machine are used to build the images that will be used in a non-production and production environment. This can really give you confidence in what you're deploying and reduce the old "it works on my machine" type issues. The next topic we need to talk about though is image tagging, as it's a very important issue when you start to push images past your development machine. There are lots of ways to handle image tagging, but there are some general practices that you'll see. Semantic versioning or SEMVer is very common when it comes to assigning image versions. Your images will also have different tags assigned to them at different times during their life cycle, as we'll see shortly. And there are two different types of tags, stable tags and unique tags. Let's start by looking at stable tags. Okay, so we're going to start to look at what stable images are and what they're used for. They're primarily used as base images. For example, you inherit from them when you build your images, but they're rarely used for deployments themselves. The reason being that they will actually change over time. So if you pull the same stable image today and again next week, you can actually get two different images. So let's take a look at why that is. Well, we start by creating an image, and it is assigned an ID or a digest. And these are actually really long hexadecimal values that I've just shortened for the example here. After that, we assign some tags to the image. Here you can see we've assigned it 1.0 as that's its version. But we've also assigned it 1 as it's the latest image in the 1 major version. And we've assigned it the latest tag as it's the overall latest image in this registry. So we move along with our codebase and we're at the point where we need to release a new version. So we give it the new version tag of 1.1. That's its application version. However, now the 1 tag and the latest tag that we created previously no longer point to the correct image. So we assign those to the new image as well, effectively moving those tags to point to the correct image. Now, remember before we spoke about base image updates? Well, that can happen as well. So we end up with a scenario where our source doesn't actually change, but our base image requires a new image to be created. That's exactly what you can see here. We've got a new digest that has been generated, and now all our tags need to be updated. They all need to move along to point to the correct latest image. And we carry on like this. The next update is actually a major release of our software. It's version 2.0. So we have a couple of new tags, 2.0 and the 2 major version. And to keep everything up to date, we're going to move our latest tag along. Notice how the v1 tags remain on the previous image though, because they don't apply to this new image we've created. Okay, so the next commit introduces version 2.1 of our software, which, just like before, requires us to move the version 2 and the latest tag along. Again, once more, we next have a base image update. That generates a new digest, which means we have to move all 3 of our tags along to keep them in line. After this, some more time passes, and we're again at the junction where we release a major version update. Version 3 of our application. Here we create the new version 3.0 and version 3 tags. Once more, the latest tag moves along to keep in sync. And you can see a pattern developing here. Here we release version 3.1, so version 3 and latest moves along. And again, you can see a base image update. The codebase hasn't changed, but the base image we inherit from has, so all 3 tags have to go along with it. One thing we haven't shown here is that the older v1 and v2 tags will most likely be updated as well, even though later software versions have been released. For example, when base images that they depend on are updated. This is important for people who use your images as base images themselves. Now, this is great. But the problem you end up with is that you have no guarantee of what image you're getting for a tag. For example, if I'm running in Kubernetes and one of my pods dies and needs to be recreated, Kubernetes handles all of that for me. That's one of the great features about Kubernetes. But it does that by doing a fresh pull. And that means it may get a different image than what it had previously. And so you can end up with inconsistency between the different pods in your cluster. So how do you get around this? Well, that's where unique tags come into play. Unique tags are what you should use for deployments because of exactly that issue. They allow you to gain confidence in what you're actually deploying out to your running instances. Now, I could use the image ID or digest for sure, but as I said before, they're like 30 odd characters of hex values, so not very readable. What generally is best practice is to assign a unique ID to each image as you build it. What that unique ID is tied to will vary by system. However, you'll most commonly see it being aligned to the build ID and also the build system if you have multiple systems building your images. Tying your unique image tags to builds allows you to generate a new readable ID for every image, even when only the change is a base image update, which is something that wouldn't be reflected if you tied to commit IDs, for example. So how does this image tagging theory apply to Sitecore images? Well, when you're tagging in Sitecore, as I mentioned earlier, you're going to be using your Docker Compose file to build your images using your CI system of choice. So you'll most likely be building all of your images at the same time. And this will mean that all of your images will have the same unique tag each time they're built. So that will, in most cases, mean that your tags will be aligned across your architecture, giving you consistency in what you're deploying out. What you'll have to figure out, though, is what's going to be the best trigger for your system. Code changes and base updates are the 2 most common ones, but maybe your system has other triggers that require new images to be built as well. So once you've built and tagged your images, you need to push them somewhere. And that means that other developers and your orchestrator can access them. And this is where the container registry comes in. With Sitecore most commonly being hosted in Azure, you'll most likely be working with Azure container registries. And there's a couple of things to bear in mind if you're doing that. Network proximity is super important. You want to set up your ACR instance in the same region as your orchestrator, and ideally close to your developers as well if possible. For larger sites, you can geo-distribute your ACR instance. If you need to have your application deployed to different regions, it's definitely a good thing to look into. Finally, you can choose whether or not you want your images to be publicly available or not by choosing whether you want to set up authentication on your ACR instance. You can see a link here with further best practices for ACR instances that Microsoft recommend following. Okay, so let's take a look at some of this in action. So I've loaded up Visual Studio here, and I've opened the MVP solution we've looked at previously. Now this solution's moved on since we looked at it in our last video. I'm just going to talk about a couple of the changes here. The first one that applies to what we're going to look at today is the changes to the Docker Compose functionality. You'll see we now have two Docker Compose files, a Docker Compose.yaml and a Docker Compose.override.yaml. The override functionality is an out-of-the-box feature provided by Docker, allowing you to change existing values in the Docker Compose and also add your own. So if we take a look at this Docker Compose file here, this is actually the standard out-of-the-box XM Docker Compose issued by Sitecore. We haven't made any changes to that. All the changes and customizations we're making, we're doing in this override file. And that means we get a clear separation between our customizations and out-of-the-box functionality. Something that should be very familiar to existing Sitecore developers. And if we take a look in this Docker Compose override file, you can see there's examples where we're creating entirely new containers. For example, the rendering host. That doesn't exist in the out-of-the-box XM Docker Compose, so we're adding an entirely new container definition in here. But if we scroll down a bit, we can also see some examples where we're just customizing existing ones. In most of the cases, this just involves things like adding solution-specific volume mappings, for example, showing that where our Solr and our SQL volumes are mapped for this individual solution itself. The next thing I want to take a look at is the Azure Pipelines definition. This is a YAML configuration document which specifies our entire CI/CD Azure DevOps pipeline. And it's all here in the solution, which is amazing because it means that then any changes to our delivery pipeline are source controlled, versioned, and released alongside the version of the source code that they apply to. It's a really nice way of working. And we can see it's pretty easy to read. You can see which branches we point to. And then you can see we start to work on the different stages. Each stage represents a different phase of the deployment. We start off with the build images and pushing out to our Azure Container Registry. And that's what we're going to focus on today, the different steps involved in that task. Now, I could show you that in Visual Studio here, but it's actually a bit easier to read if we go into Azure DevOps itself and open up the file in there. So let's do that. So I've hopped over to Azure DevOps here, and you can see we have our technical marketing organization with an MVP site project in there. What I'm going to do is I'm going to use this blue icon here, and I'm going to hop straight over to the pipelines that have been defined for that project. Here you can see we have a single pipeline used to deploy out the Sitecore MVP site. We can load that up, and now we can see a history of all the different runs that have happened and whether they've been successful or not. We can also see the two different stages which are defined. We can see the first stage is building the images and pushing them to the Azure Container Registry. And we can see the second stage is then using that artifact to populate the non-production staging instance. So let's use this edit button up here. And let's just take a look at that YAML file in a bit more detail. As I mentioned before, we're going to be focusing on the first stage only in this video, building our images and pushing them out to the container registry. So if we scroll down a bit, this is where the stages start to be defined. And you can see we set the first stage to be a build stage and we give it a friendly name. After that, you then set up your jobs, and each job has a series of sequential steps that get executed. If we start off with the first one, this is used to build the images we just talked about. The reason I wanted to show you this YAML file inside Azure DevOps instead of in Visual Studio though, is you do get a nice GUI editor for each of these tasks, if that's what you'd prefer. You can just click this little settings link for each, and then you get a form-based interface allowing you to change the values. So the first one we do here is actually, as I said, building our container images. We specify the Docker Compose file that's used and the Docker Compose override file we just talked about. And then we set some environment variables. These are environment variables that are specific to building images through the CI server and not locally. So they populate values, for example, like our ACR container URL. You typically don't want to push images from your local machine to your container registry. You do it from your CI server, so you populate that value from a variable. We then specify the action, which is building these service images. And finally, we add some additional image tags. Remember we talked earlier about unique tags. Here we're adding a tag which is a combination of the build number assigned by Azure DevOps and also the branch name. So any images which we'll see in the container registry, and we'll take a look shortly, it becomes really easy to identify which build created them and which branch they were created from. So once that was completed, then we push our images out to the container registry. Again, we're specifying our Docker Compose YAML files, but this time the difference is we're using the push services action. Now you may ask why we don't do build and push at the same time, and that's because we have a condition set on this task, which you can see at the bottom. And that basically says this task should only execute for builds that happen on the master branch. This basically is saying we don't want builds from all of our different temporary short-lived branches pushing images into our container registry, because that could pollute what's in there. People will use the wrong image by mistake, and it also drives up the cost of the ACR. You're charged on the amount of data that's stored in there. So once that's finished, we've kind of completed the build of the images and the push to the container registry. But there are a couple more preparation tasks we need to do to get ready to actually build this out. If you think back to the flow I showed at the start of this video, we know that later on we're going to be pushing this out to Kubernetes. We're going to have to deploy some specifications there. And we know we're going to have to deploy some content out there as well. So what we're going to do is we're going to create a build asset which contains both of those things for us. The Kubernetes specs and the serialization files are both present in my solution. So I just need to pull them out and put them somewhere Azure DevOps can access them. We start with the Kubernetes specs. We basically point it to the correct folder. We're going to select all the files in there because they're all applicable. And then we choose where we want them to go. We're going to use the build artifact staging directory, and we're going to create a Kubernetes specs folder in there to house these. After that, we do something similar with the serialization files. This is slightly different. We basically want to recursively search through the source folder, and we're going to pull out our Sitecore JSON, we're going to pull out any module JSON, and we're going to pull out any files that exist within an items folder, because those contain the actual deserialized content items we want. We're going to take all of those, and we're going to put them inside this serialization folder, again, in the build.artifact staging directory. Once that's completed, we then execute our final task for this stage in the build pipeline, and that is a publish pipeline artifacts task. This basically takes everything in the system artifacts directory. It's going to basically wrap it all up in an artifact and give it a key name, which we've chosen sitecore.mvp-build number. This means that it's going to be really easy to identify where an artifact comes from if we need to look at it further down the track. And that's the end of the first stage. At that point, we have a completely built set of Sitecore container images deployed to our container registry, and we have a build asset ready to be deployed to our Kubernetes or AKS environments. So the last thing I want to show you here is just how these container images look in my container registry. I've loaded up the Azure portal here, and I'm going to load up these containers. Here you can see each of the different images that are there. So we can load one of them up. And you can see how the different tags are set up. You can see the build number -build branch tag there, and also the stable tag, representing the actual version that's being built. Okay, so I just want to finish up with a couple of tips and tricks that you want to make sure you follow when building your images. Just like with non-container based development, you still don't want to store application secrets in your repository. Instead, you want to store these in variables that are passed in at build time. And the same is true with build secrets. Don't store them in your source control system either. Pass them in as variables. Don't deploy using stable images like latest, as you have no control over what's actually being deployed out to your system over time. Ensure you have an automated build trigger for each scenario that requires a new image build to happen. And finally, make sure you run cleanup tasks on your Azure Container Registry instance to keep the size and costs of running it down. Thanks for watching, and don't forget to follow the Learn Sitecore hashtag for future videos.